hello. My name is John Michelson, and I'm from Audio Video Design in Newton, Massachusetts. I'm sitting here with Joseph D'Appolito, one of the premier speaker designers in, I would say, the world, never mind just the United States. And I thought that I would ask him a few questions about the industry and his experience in it. So, Joe, thank you.
Thank you.
My first question is, what have you seen in terms of speakers primarily? What are the big changes in the time that you've been in? Is it materials? Is it computer-aided design? What aspect has really made the biggest difference?
Well, the general answer to your question is yes.
Okay.
There is, especially in the last decade, there's been a tremendous improvement in materials technology as it relates to the manufacture of drivers, tweeters, mid-range, and woofers. There are new exotic cone materials. There are new magnetic materials for the motor structure. And so you have the material side, but then there's been a fabulous development in software. Finite element analysis techniques like that allow us to very accurately model what the motors are going to do,
Right.
how the cones are going to break up so that we can damp them
I
properly.
was told now you can do it in the software instead of building it.
You can do it in the software, and when you build it, it will be right.
Right. Right.
Now, with regard to loudspeaker system design, there have been two really important developments since, say, starting the early 90s. One is the use of PC-based acoustic measurement systems, where before you had to spend tens of thousands of dollars worth of laboratory equipment. Now with a PC and a particular card and a microphone, you can get phenomenally accurate measurements of what's happening. And the way we design loudspeakers today is, you come up with a prototype design, you put the drivers in what you think would be a good enclosure, and you take a lot of measurements. You measure the response of the individual drivers, their phase response, their frequency response, their acoustic centers, and you put all that information in a software package. And the software package allows you to design very close to optimum crossover networks in software. When you're all done, you can build the networks and they'll behave exactly
The way you expect.
as the models predicted. Now, that's not the end of the design. Once you have a very accurate model, now you can do a lot of listening tests and you can say, oh, that mid-range is a little recessed. I have to tweak it, push it out a little bit. How do I do that? Well, we have a model. All I have to do is change a few components in the model, and it will graph the
And the
change.
model will tell you that this is what.
So it
needs to be
saves
done.
hundreds of hours of
Right.
soldering this little capacitor in, changing that little resistor. It's all gone. So it's not that there is a dual process here. There's the solid engineering, then there's the listening tests. But the solid engineering provides us with the models to rapidly zero in on the particular sound we want from a loudspeaker.